Today, we're going to pull back the curtain and unlock the surprisingly simple secrets hidden inside numbers. I mean, you use them every single day, but what really makes them tick? Let's dive in and find out.
Seriously, think about it. Numbers are pretty much the invisible architecture of our entire world. They're the language we use to measure, to count, and to make sense of, well, everything around us, every single day.
We use them for all sorts of things, right? Counting the people in a room, handling cash, figuring out how far away something is, or even just checking our score on a test. They are absolutely fundamental to how our modern lives work.
So to really get how numbers function, we're going to start by taking a big one and just breaking it down. You can think of it like popping the hood of a car to see how the engine actually operates.
Let's use this number as our example, 45,678. Now, at a glance, it just looks like a single value, but it's actually a team of individual digits. And trust me, each one has a very specific job to do.
So here's the big question. How do we know that the 4 in that number is worth so much more than the 8? Well, the secret really comes down to two key ideas.
First, you've got something called face value, which is honestly as simple as it sounds. The face value of a digit is just the digit itself. A 5 is a 5. But the real power, the magic, comes from its place value. That's the value a digit gets based on its position in the number. And that, my friends, is what truly matters. Just look at this table. It shows the huge difference between the two. The digit 4 has a face value of just, 4. But because it's sitting in the 10,000s place, its place value is a massive 40,000. This is the core concept, the main takeaway. In our number system, position is everything.
We can also see this with something called expanded form. It's like we're stretching the number out to see all of its place values added together. Any big number is really just the sum of its parts, with each part getting its importance from its position.
Okay, so now that we understand what gives each digit its value, we can use that knowledge to start comparing numbers and putting them in order. Every number has two direct neighbors. The number that comes just after it is called its successor, and the one that comes just before it is its predecessor. Simple as that. For instance, if we take the number 19,642, its predecessor is just one less, so 19,641, and its successor is one more, 19,643.
Now, when we have a whole group of numbers, we can arrange them in two main ways. Ascending order means going from smallest to greatest, kind of like climbing up a flight of stairs. Descending order is the exact opposite, going from the greatest number down to the smallest, like walking back down.
Let's try it out. To put these three numbers in ascending order, we just start by finding the smallest one. That's 23,456. Then we find the next smallest, which is 45,678. And that, of course, leaves the largest number for last. And there you have it, a perfectly ordered set.
All right, for our final section, let's look at numbers from a couple of totally different perspectives. We'll check out a way to talk about them approximately, and then we'll see how people wrote them a very, very long time ago.
Sometimes we don't need a perfectly exact number. An about value is totally fine. And that's where rounding comes in. The rule is super simple. If a digit is between 0 and 4, you round down. If it's between 5 and 9, you round up. It's a really useful shortcut for making quick estimates.
Now for a little history lesson. Have you ever seen numbers written out with letters like I, V, or X, maybe on an old clock face or in the credits of a movie? What exactly is going on there? Those are Roman numerals, an ancient system for counting. And what's so fascinating is that this system doesn't use place value at all. Instead, it just uses combinations of these 7 core symbols. The position of an X doesn't change its value from 10. You just add more symbols to make a bigger number. It really makes you appreciate just how powerful and elegant our own place value system is.
All right, we have covered a lot of ground. So let's do a quick 2-question check-in to see if these ideas have clicked. Ready?
First question for you. What is this successor? That's the number that comes right after 79,999.
The answer is 80,000. Adding just 1 to 79,999 is enough to tip it over to the next major milestone. Nice. Okay, one more. What is the predecessor, so the number that comes just before 100,000? And the answer is 99,999. It's the exact same logic, just going in reverse. You just subtract 1. Perfect.
So after all this, what's the one big secret that every number holds? It's that a number isn't just some static thing. It's a story told by its digits, where the meaning of each character depends entirely on its place in line. That simple idea is the engine that drives all of modern mathematics. Thanks for watching.